It's Mrs. Weefy here to talk about Lesson 5, Metallic Bonds and the Properties of Metals. Now, metallic bonds are different from ionic bonds in that we are dealing with just all metals rather than metals combining with nonmetals. This is based on the attraction of positive and negative charges between like metal atoms. Now, one special thing about metallic bonds is that it involves the electron C model. So here's what happens. Within a metal lattice, like a crystal lattice of ionic compounds, metal atoms do not share electrons. The outer energy levels of the metal atoms overlap, forming a C. So if you have a metal that has electrons in the 3s sublevel, then what happens is that 3s sublevel between all the metal atoms are going to overlap, kind of meshing together, forming this C. Those metal atoms then donate their valence electrons to that surrounding C, and the electrons are able to move freely within the C. Those electrons that are donated are called delocalized electrons. They're also called mobile electrons because they're moving. But those delocalized electrons are kind of shared between all of the metal atoms in a metallic bond because of that electron C. They're just free to move around those metal ions. So here's a little diagram. When you see the pink flashes, those pink flashes represent the electrons within the electron C. So you can see the metal ions, they have a positive charge because they've donated those electrons. So where you see all this pink right here, those are like the S sublevel, the D sublevels that are kind of like overlapping, and those electrons are just free to move within that electron C. So therefore, a metallic bond is the attraction between the metal cations for those delocalized mobile electrons. Now, that electron C contributes to the properties of the metals, explains the metallic bonding. The melting and boiling points of the metals, they're generally kind of high. Mercury is already a liquid, so it doesn't really have a melting point, but tungsten, with the symbol W, melts at 3,422 degrees Celsius. In general, the melting and boiling points are going to vary, and that's dependent on the number of electrons that you have in that electron C. These melting and boiling points are pretty high because of the very tight, crowded lattice structure of the metals. The boiling points are more extreme because the cations and the electrons, they have to separate, which requires a little bit more energy. Now, metals in general are malleable, ductile, and very durable, which means that they are strong. And this is because the moving particles can slide past each other to form sheets or wire. The metal ions and the electrons C, they're kind of arranged on sheets on top of one another. And so if you hit them with a hammer, or you try to stretch them out, those sheets are going to just slide past each other, making them more and more thinner like foils and the copper wiring that we have. The cations are strongly attracted to the electrons, so it makes those metals durable, strong. They also have thermal conductivity and electrical conductivity, and that has to do with those mobile electrons in the electron C. The moving electrons move the heat throughout the metal, making them good conductors, and the electrical current is, we know, a flow of negative charge, but this is because the electrons, which is negative, carries that current throughout the metal. Lastly, metals are hard and have strength. And if we take a look at the transition metals, they're a lot harder and stronger than those in group 1 and group 2. The moving electrons, the delocalized electrons, consist of those 2 electrons in the S sublevel and then D block electrons. Both the S and the D electrons are donated to the electron C for those transition metals. The more mobile electrons a metal has, that is, the more d electrons that are contributed, the harder and the stronger the metal is. And that concludes this part of Unit 5 on ionic and metallic bonds.